Hello, it's David Williams from the Electronic Engineering Technology Department at Okanagan College, and the video today is on clipper circuits. And a clipper circuit is a circuit that either cuts off or clips a part of an AC signal. And diodes are typically used to do this, and you can see in this little circuit here, this is a circuit to prevent a signal from driving these speakers, these headphone speakers, too loudly. And these two diodes here are going to clip off any signal that's above their particular voltage, depending on what kind of diode we're looking at here. And we're going to look at a few examples of how these clipper circuits work. Now here's a simple clipper circuit, and before we get into details, I should note that this circuit, as well as the following ones in this video, are taken from Tony Kupalt's documentation that can be found at the website allaboutcircuits.com. It's a great electronics document, online textbook covering the spectrum of AC and DC electrical circuits, semiconductors, digital circuits, all sorts of really good information. And so these examples are taken straight from that document. So what's happening in this circuit? Well, during the positive half of this cycle, this diode here is going to be reverse biased, which means that no current will be flowing in this circuit. Therefore, there is not going to be any voltage drop across this 1 kilo ohm resistor. So the voltage probes here that are measuring at the top here and at the bottom here are going to measure the full voltage swing. So I'm just drawing it slightly offset if I can here, just so they should be basically the same. I'm just showing it offset a little bit so you can see both of the signals. So that's in the positive half of the input signal. The output signal, which is the one V2 here, is going to be the exact same. So on the negative half of the cycle, this voltage here needs to be about 0.7 volts higher than the voltage on this side in order for this diode to become forward biased, and then the voltage across the diode is not going to change much from that 0.7 volts. And that's not going to happen until our input voltage gets down to about minus 0.7 volts, and then at that point it's going to be a constant 0.7 volts, and then at this point again, when the input's at about minus 0.7 volts, the diodes are going to become reverse biased again, and then the input and the output will follow the input. And we're just going to get this signal repeating over and over and over again. So here again, the diode is forward biased, so it's 0.7 volts across it, and we're going to get this repeating over and over again, and it's basically cut off most of the negative part of the cycle. Now this circuit adds a second diode in the opposite orientation as the first diode. So when one of these diodes is forward biased, the other one's sure to be reverse biased, and then what we'll see is there'll be a period where neither one of them is forward biased. So starting with at the beginning here, where the input voltage, which I've designated here with the red signal, that input voltage there is at 0 volts. So 0 volts applied across this diode and applied across this diode means that both of these diodes are going to be reverse biased. There's no current flowing in either one of them. Now as the voltage starts to increase, once it gets above 0.7 volts, this diode here, the first diode, is going to become forward biased, and therefore it's going to maintain its 0.7 volts approximately. Current will be going through it, and we'll maintain that 0.7 volts until we get to the point where the input signal drops down below 0.7 volts, and now that diode is again reverse biased. No current will be going through it, no current's going through the other one either, so the full voltage from the input, or whatever the input voltage is, will be seen at the output. Now going in the negative direction, this side of the diode needs to be at a higher voltage than this side of the diode, so we need to get down to an input voltage of about minus 0.7 volts before this diode will become forward biased and start conducting. So up until that point, the output will follow the input, and then at about 0.7 volts from the input, the output's going to maintain that 0.7 volts, and then when the input again gets below negative 0.7 volts, the diode will again become reverse biased. No current going through this diode, no current going through this diode. So whatever is at the input is going to be showing up at the output. And so we get a positive clipping, a clipping on the positive side, as well as a clipping on the negative side. And hopefully you can see from these two examples that if I had only this diode, the one that's forward biased when the input signal is positive, then what I would have is a clipping of the positive part of the cycle. Now, one more example to show you. I'm just going to draw this one on the fly here. Now this one's a little bit different in that we're going to have a diode here as well as a DC offset applied to this diode, and a second diode over here in the opposite orientation, and also along with a DC biasing to offset it somewhat. So we're going to have our 5-volt input signal again at 1 kilohertz, although the frequency in this case doesn't really matter so much, because I don't care about the time scale. What is important though here is what are these two offsets? Well, this first one is going to be at 1.3 volts. The second one is going to be at 2.3 volts, but you see it's in the opposite orientation, so relative to this one it's negative 2.3 volts. And then I'll have my output over here. I'll do my output in blue, V out, and my input is red. So what's applied by this sinusoidal source. And I'm going to need to plot this out. So again, I have a sinusoidal input with a 5-volt peak. And let's take a look at what happens at the output when we apply this input signal. Well, this input, in order for this particular diode to become forward biased, we need to have 0.7 volts across it. But we also have this offset of 1.3 volts. So we're actually going to need to have, relative to the ground point, I guess, or the 0-volt reference from this sinusoidal input, we're going to need to be 0.7 volts above 1.3 volts. We're going to actually need to be at 2 volts before this diode right here becomes forward biased. When it's not forward biased, let's say on the positive part of the cycle, this one is definitely not going to be forward biased, but on the positive part of the cycle, when this one is not forward biased, we'll have no current flowing through either one of these diodes. No current in either one of the diodes. So no current through this resistor, no voltage drop across the resistor, so therefore the V out has to follow the V in. So on this positive half of the cycle, we'll have the V out following V in up until, because I probably drew that too high, up until about 2 volts. So that point's 2 volts, even though it's probably not quite to scale, since this point up here is 5 volts. So at 2 volts, and then at 2 volts the diode becomes forward biased. No more voltage drop, because it's just going to take all the current through it. Now, going in the negative cycle, this point over here has to be 0.7 volts above this point over here, but we have this biasing offset from this we've got this offset from this 2.3 volt source. So the second diode will not become forward biased until the input signal gets 0.7 volts below negative 2.3 volts. So in other words, at minus 3 volts, that's when this diode here becomes forward biased. In the negative half of the cycle, of course, this diode will always be reverse biased, so no current will be through this diode. But it's not until at a minus 3 volt input that this diode becomes forward biased, so current will go through that, so we're going to have clipping at that minus 3 volt point. So no clipping, no clipping, no clipping. At minus 3 volts we have clipping. So right at that point we're going to be at minus 3 volts. And then when the input falls again below minus 3 volts, the output will follow the input. Neither of the diodes is forward biased. And then we get up to plus 2 volts. Clipping due to the first diode becoming forward biased. And then way over here we'll have clipping due to the second diode becoming forward biased, and this is just going to repeat itself over and over and over again, so we're able to clip at 2 volts and minus 3 volts. Now, one major practical application of this is if you wanted to create a half-wave rectifier, and one that cuts off half of the signal, either the positive half or the negative half. Stay tuned for a video on that in the near future. But a couple of other, or at least one other reason that you would need to have clippers like this is for protection. And we saw that actually in the beginning there with the clipper that was clipping off the audio signal, so it wouldn't drive the headphones to be too loud, so that when you're listening to it you won't become deaf, hopefully. But let's say we have here's another example of protection. So let's say this is an IC. I'm just going to draw this roughly here. That has a 5-volt supply referenced here to the ground signal, and at one of the inputs here, this is an input signal, maybe coming from an analog voltage, or maybe it's even a digital signal, either a 1 or a 0, a 5 volt or a 0 volt. But there is the potential that this signal, or this pin here, could be driven to a voltage higher than 5 volts or lower than ground, which could potentially cause some problems, depending if the internal circuitry, whatever's in here, can handle that high voltage. But we can protect against that by connecting 2 diodes. One diode like this to ground, and one diode like this to the power supply, the VCC or VDD or whatever you want to call it. And then this is going to go to the circuitry, to the circuit. Now, if this voltage falls below 0 volts by some amount, depending on the forward bias of this diode, the forward voltage of this diode falls below 0 volts, this diode all of a sudden becomes forward biased, and we will have current through this diode as opposed to current into the circuit, as opposed to over voltage into the circuit. So we're going to have clipping at something around minus 0.7 volts or minus 0.3 volts, depending on the type of diode, the type of diode this is. And similarly here on the second diode, if the input voltage gets above 5.3 volts, 5.7 volts, again depending on the forward voltage of this diode, if that voltage gets above that point, this diode becomes forward biased and it clips the voltage that's going to the circuit to about 5.3 to 5.7 volts and protects the circuit from any over voltage. So I hope you learned a little bit about clipping circuits in this video, and I will see you in the next one.